Hey everybody, this is Larry. This is me doing a second bonus question. Man, I don't know. Just figure I put it on YouTube so maybe people can figure something out from this. This is not going to be my usual video in the sense that I am going to solve it live, but I know what the answer is kind of. But I am out of practice with this problem. So it's August 15 or 14 or 13, whatever. August 14, 2022. And earlier today, we did a contest where this was the Q4, right? The Q4 was count special integers. And I kind of did it this way. You could watch the video. I'll put a link below on the original video. But I knew that I could have done digit DP, but I was so out of shape in it that I was trying to figure out another way. But I think if I had just been more practice, even though I know how to do it, I would have been, just want to see how that goes if I just practice more, right? And someone told me that there's another problem that's almost the same, but this time, so the idea is going to be very similar, but I am going to try to solve it with digit DP. I don't know how much explaining I'm going to do, so maybe this is just experimental. This is additional Larry practice, and you're watching me just practicing even though I knew the answer kind of, because this is just implementation. And also with, I think that's the one thing that for me is that for digit DP specifically, and this probably what is true for a lot of things, but for me specifically is that I do know the concepts, but I am often like they're off by these things have to be very careful, and I'm often just getting off by once in the past, so that's why I'm a little bit shying away from it in the past, at least in terms of contests. So but these things do get more familiar and more easier as you practice, like everything that we do on this server and channel or whatever terminology we use. So yeah, so hopefully that makes sense. Hit the like button, hit the subscribe button, join me on Discord. If I didn't explain it that well in this video and you only came on, if you Google this problem and led you to this video and I didn't explain that well, I apologize. But this was kind of for me, maybe, and then if you want to watch it, fine. If not, watch on 2x, do whatever, and then see how we think about it. Okay. So here, there is a little bit difference. So between this one, which I haven't done yet, actually. So, yeah. So the difference between this one is that on the contest, and I guess this part I am explaining a little bit. On the contest, it gives you that all the digits are unique, where for the problem I'm solving right now, it's the opposite of that, right? It has at least one repeated digit. Now, one, obviously if you combine them, you get n, right? So that means that n minus this, if I do n minus this problem, like if I just copy and paste this and I wrote n minus that would be the answer. And of course I can write a digit DP specifically for this problem and then n minus that to get the answer. Right, so there are already two things you can do, and during a contest, whatever is easier for you to visualize and get quicker and fewer mistakes, just do it with it. Right, there's no right way. Sometimes there is a more optimal way. So I don't know. So that said, for this one, I don't want. I guess I'm just setting my goals for myself. Adding constraints because I don't want, like it's not practice if I'm just doing things that I know how to do, right? So I'm deliberately setting constraints on myself so that I could write it in a different way, right? I'm not here to memorize. I'm here to figure out how, especially in math, a lot of things, if A plus B is equal to C and C minus B is equal to A, then, it's up to you to figure out if you want to, calculate A or B or C, and then combine them in interesting ways. And of course, they all have different implementations. But it also means that you have to, now that you define the problem, you have to write the code very specifically for it, right? And so here, I'm not going to do the n minus uniqueness thing. I'm going to do at least one repeated digit thing. So let's think about what that would look like. So digit DP, I'm going to not be that creative with the naming. And of course, I'm just going to do whatchamacallit, functools cache. If you want to read up on it, that's from here. The idea is that it does memorization for you. We'll go over maybe how it works later, but for me, just I'm focusing on implementation right now. And also because and why I can do that is that we'll think about the thing, but for digit DP, the complexity n is not the input n. The complexity n is often the length of the input, right? So, and the length of the input is 10 to the 9, so it's gonna be like 10. So, even 10 to the 5th is fast enough as long as we're not really, really, really sloppy or something. So that's why for now I'm not really thinking about that. So yeah. First of all, let's create a cache. Let's just call it S. So we want to convert this to a string, and then we change it to a list, so that is a list of characters, and then and then we map into it so that now it's a number, and then we convert it back to a list. I know that you don't have to write out list, but I'm old school Python too, I guess. I don't know. Okay. And let's just say the real n, or big N, is length of S, right? So here, we're going to calculate one. We're going to brute force calculating all the digits one at a time, right? So we have an index that's just, which index of the number that we're calculating on. Let's see. I think in this case, okay, one is, let's just say is prefix maybe. We'll go over this in a little bit, but this is very common. The idea here is kind of similar to, how do I explain it? I am explaining it instead of just implementing it, I know. But for example, if you have, a random number, let's say one, something like this, well, the idea here is that you want to the idea here is that when you do a brute force iteration, well, let's say you have 0 and it's the first digit, right? And then that means that I put xxx, but the idea behind x is that x can be any number from 0 to 9, right? And here 1, well, it cannot be an x here because it can only go up to 2. So then now it can only be 0 or 1, right? Or xx previously. So then now, and 1, 2, this cannot be true. So then now we have 5, but before that you have 1, 2, 0x, 1, 2, 1x, 1, 2, 2x, dot, 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 right? So this is prefix just means that do we go, I mean, that's the way, that's my notation. Maybe it's a little bit off. I often, with these things, I remember the concept from when I first learned these things, maybe like 20 years ago now. I know your reactions may be that Larry looks young, and you're probably right. But still, I learned it that long ago. And so my terminology and notations may be a little bit off because I'm of what's standard these days, because people have done amazing things to kind of clean up code, to write like really tight code, which is actually kind of, and then everyone just copy off each other, which is kind of cool in an innovative way, because everyone's trying to like optimize it almost, right? But for me, I'm here. The way that I find myself learning is just to create things from first principles, as much, or maybe not first principles, but like my own principles, and so my terminology may be really off. But yeah, so you have is prefix to calculate that. So that in this case, if this is the prefix, it only goes up to the digit that we're looking at. So that's kind of the idea there. And then the other one is that we don't want to count leading zeros. So here, for example, if we have a leading 0, it's technically a 3-digit. And there are a couple of ways you can handle it depending on how you want to do it. One way you can do it is just like having an outside for loop that handles like, okay, let's do it for every 3 or yeah, you can do it with like, hey, let's do it for every zero digit. Well, maybe not zero digit. That's misspoken. Try for every one digit number, two digit number, three number. Then there, you don't have to worry about leading zeros. But this is the way that I'm doing it. Is that I do have these zeros, but it's whether that I think the two ways of doing it. Maybe I'll practice the other way another time. But here, for me, it's just about having, okay, now that, let's just say we do assume, oh, in this case, it's actually, yeah, okay, this is a little bit awkward because this should be a one maybe. But, this is just explanation or visualization. So it doesn't have to be precise per se, maybe. But maybe that's not true. But anyway, so then the idea here is that, yeah, this is just our way of skipping digits, really, but only at the beginning of zeros. So let's just say maybe is leading, or led, maybe. Like we already had a digit or something like that. And then just a mask. This is just a lazy way of, or maybe, and also, so this is led, this is prefix, and then I want to have one more, which is that repeated, right? That means that has any digit already repeated, it changes some state of things. But yeah. And the bit mask is just, you can think of it as a bit, as a vector map, or a Boolean vector or a Boolean list that basically let us know whether any number from 0 to 9, that wasn't the 9, but from 0 to 9 I used any digit, right? So for example, yeah, I'm not going to go over bitmask dimension. I would also say that digit DP is a little bit of a advanced DP topic. So I'm not going to go over some of the DP principle as much as I would normally. Definitely, if you are struggling with basic DP principles, check out my other videos. Depending on the day, I usually do feel like I try enough to explain it pretty well. But this is a bonus video. So anyway, so okay, so index is equal to n, then we're done. But we don't automatically return a 1, right? We return a 1 if repeated is true. Because if there are no repeated digits, we return 0. Yeah, and then now we just do a for loop. Okay, so if is prefix, what does that mean? If this is the prefix, then we have to keep track of the first one, right? Yeah. So basically, we want to go up to a limit. So let's just call it limit, maybe. Is equal to 10 from 0 to 9, non-inclusive. So if it is prefix, then limit is equal to s of index. And then now we do, our current digit in range to the limit, because we don't include the number. If this is the limit, we go under it, because then, we'll add another thing later, maybe. Okay, so that means that and maybe I have to do a better job separating out the zeros. So let's do that. Okay, let's just say this goes to 1, pass for now, and then let's handle the zeros. Okay, if LED is such a terrible name. Let's just say is LED. This is terrible. Okay, I don't know how to name things. But okay, so if we already had a leading 0, this part is going to be handle 0. Let's just add a comment here. So if we have a handle 0, if we already had a leading 0, then we can just use 0, right? So that means that, and I forgot to add a total. That means that total, we could just increment it by go. We index by 1, because now we're going with the next number, we use 0. Is prefix, is it prefix? No. Well, I think I have to do another if statement here. Maybe that's a little bit sloppy. Hmm. Um, because the idea here is that if 0 is less than limit, right? Basically, if the limit is 0, meaning that this is prefix and the limit and the number is 0, we do not, do this free loop thing, right? But yeah, because then we'll handle it later with the is prefix. So yeah, so if 0 is equal to the limit, less than the limit, then we could put a 0 down. And what happens when we put a 0 down? Well, when we put a 0 down, the prefix is no longer true in this case, by definition. So we have false, is led. Yeah, I mean, it already is led, so it's true. And then mask, we just use the 0. Yeah. So I also made a mistake again. So this is just equal to 1. So that should say 1. I also made a mistake because I have to check that n mask. Oops. 1 is equal to 0. Don't forget the parens. Basically, it's saying that we haven't used yet. Then we do this. Else, if it's not leading 0, then we can actually just do this to go to a smaller digit. Is the idea. Is prefix still? No, it's not, because there's fewer digits. And we do not use this yet, right? Oh, I'm missing a parameter. Yeah, okay. So here, I guess we don't. I forgot that we don't need this to be 0 because I'm thinking of the other problem, even though I know that I said I shouldn't. But so yeah, so here we do mask over 1, but then to repeat it, we want mask n 1 is equal to 1, something like that. So if this is already used, we make the repeated true. I know this is not complete. Hang on, I'm just typing really slowly. It's repeated or this thing, right? Because basically, this means that if it's already repeated, then we already satisfy this condition. Otherwise, we check to see whether this makes it repeated. If this already exists, then this means that we already use it, so that's fine. Otherwise, here we also just pass along repeated and mask because this is just skipping to a smaller number or smaller digit or smaller fewer digit number. Okay. So 0 has a weird case because we have to handle the leading zeros and stuff like that. But now we have to handle the D for digit 1 at a time, right? So total we added to go index plus 1, assuming that this, I think this is fine. Is prefix. In this case, it will always be false because by the definition of limit, right? Because if it's prefix, this would, is led. Yeah, this is true because by just putting this down, we already have a leading 0. Repeat it. So we have repeat. We could actually use this thing that we had earlier, but and 1 to D is not equal to 0, and then the other one is masked and right. I'm not gonna go. Sorry if this looks a little bit whatever. I'm not going to go over. Not going to go over bit mask. I'm not going to consider that in scope just because, this is something that I'm just practicing for myself, but also it's a little bit advanced. So like, you should practice it elsewhere. There are a lot of bit mask problems. So yeah. Okay. And then I think that's it. Oh no, if it's prefixed, then we add in a thing as well. I guess we can move this up because then we can let's add in the digit. Let's use this one, which is that is prefix is still true because we kept the prefix digit, and then is led also true, I guess, because unless no, by definition it should be true because you're just taking a number and there are no leading zeros in the input, so that should be true. Repeated is repeated should be same thing, I guess. Repeated or mask and one limit is not equal to 0, and then mask and one limit, right? And then at the end we just return total. I think this is okay. Well, we have to kick it off first, but we start with index 0. Its prefix is true because we wanted the first digit to be bound by that prefix. Is let is false because we haven't done it yet. No repeat, and the mask is 0. Let's see how that goes. I think that should be at least it. And maybe some complicated number, but I think just to kind of see how that runs. Okay, so that looks good. I'm pretty happy about it. Let's give it a submit. Cool. Yeah. So like all dynamic programming problems, we can think of the complexity real quick. And basically, total time complexity is going to be just number of test cases, or not test cases, input cases, or input, yeah, times time per input. And total number of input is equal to, oh, I didn't do this. I did it in a weird way. Index is 0 to n. Hopefully that makes sense. Its prefix is binary. Its let is also binary. Repeated is also binary. And mask is 2 to the 10. So in total, the number of inputs is going to be O of n times 8 times 2 to the 10, which, depending on how you want to say it, but is, I don't know, I'll leave it up to you. This is technically O of n. I mean, I know how to figure that, but maybe it's more like 2 to the alpha, where alpha is the number of digits. Of course, in base 10, it's going to be 10, but I don't know. Maybe that I just find it annoying to kind of give it up that way. So that's the number of inputs, and the inputs each do about. So one more thing I would say. Well, I mean, okay. So the way that this is that each input takes all of alpha time, right? The way that I wrote it. So total time is equal to O of n times 2 to the alpha times alpha. Roughly speaking, I'm a little bit lazy on this one because you could have a tighter bound. But one thing I would say is that you can, this complexity comes from here, right? And as it turns out, you can. I mean, it's a very complicated optimization, or not complicated, like in terms of tough to understand. I think the understanding is easy, but it's just a lot of work to get it right, which is that you can, I think you can in O of 1 count, like, and yeah, I'm not going to go over the details here, but in O of 1 you can count how many numbers you have used in this mask, and then do the multiplication that way, right? Meaning that, maybe like, for example, let's say mask has 7, the mask has 7 digits used, and the limit is, I don't know, 5. You can look, you could, it's just as a hint, you could create some kind of data structure that allows you to figure out how many of those 5 are used and not. And then let's say you have 3 used and 2 unused in this, within the 1 and the limit, then you can just do 3 times whatever plus 2 times whatever, right, on the repeated and not repeated. I think maybe that's one way you can do it, though maybe not because of the way that we did this mask thing, so maybe I'm lying here. I don't know if that's true. I don't know. But these are things that I would think about optimizing if I had to. So yeah, that's pretty much all I have. And in terms of space, it's just this input, the number of inputs, because it's all 1 per space. I I know that I spent a lot of time talking this video, so I kind of failed in my task to kind of see how long it would take for me to implement this from scratch. Um, because I mean, I can't even blame it on the talking, right? Because talking it through makes it easier for me to implement. And for me, I would like to get an honest assessment on how long it would have taken. But, at the end of the day, it's just about learning. And I think the way that I did it was a very good way to learn. I know that there may be some details about DigitDP. It'll have to wait for another time. But for now, that's pretty much all I have. So, yeah. Let me know what you think. Let me know if you tried to solve this problem as well. How did you do? And did you do it with this DigitDP technology? Uh, anyway, have a great night. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.